As we start diving more and more into IT automation tools, I thought it's a good time to start learning GitHub Actions. I recently figured out how to use it to deploy applications on a Kubernetes cluster in my Homelab. So instead of spending all day sitting in front of a terminal and configuring my applications, I can just lay back and wait while it's all done automatically by GitHub Actions. This is pretty amazing and can be used in so many different ways, like building and testing code, running security checks, or deploying infrastructure. The possibilities are endless. To get started with GitHub Actions in your Homelab, I'm going to show you how to set up a new project, install a self-hosted runner on a Linux VM, and run some scripts that will deploy a simple web server on my local Kubernetes cluster. If you're interested in Homelab automation, this will be so much valuable for you. But before we start, I quickly want you to take a look at today's supporter of the video. This video is supported by Datree, a great free and open source tool that helps you to prevent Kubernetes misconfiguration. You can test your Kubernetes manifests against predefined or custom policies that include best practices, security advices, anything that should or should not be deployed on your clusters. You can also integrate it in all kubectl commands using Datree's webhook feature or your CI/CD pipelines. So before you do anything in Kubernetes, always validate your manifests in Datree. It's really amazing. And if you want to check it out, you will find a link to it in the description of this video. Okay, so let's start and let me introduce you to GitHub Actions, a platform to automate developer workflows in GitHub repositories. So whenever you're having a Git repository hosted on GitHub, where you're developing some code or defining infrastructure or application templates, you can use GitHub Actions to automate any kind of task that should happen if you're performing specific actions on this GitHub repo. So that means things like push code changes, create pull requests, or open any issues. Any of these events can trigger automatic actions. These actions are defined in YAML files inside the GitHub repo, the so-called workflows, and these workflows can run one or more jobs. Essentially, this is just a set of commands that are executed where you can do all sorts of things, such as building and testing your code, deploying applications from templates, or performing any other types of automation that you need. To make it a bit easier for you to grasp, I quickly want you to show this example here. So this is the official GitHub repository of the GitHub documentation pages, and in this GitHub repository there are multiple workflows defined to perform automatic actions. Yeah, you can see there are a lot of these workflows in here that all do different things. But there's one specific workflow I want to show you this here, the link checkdaily.yaml. So this workflow will check the documentation against any broken links. It's executed on two different types of events. One is the workflow dispatch, which is just basically a manual execution triggered in the UI. And the other event is a cron job, so it will automatically run every day. And if you scroll down, you can see the whole code that is then executed on these two types of events. I don't think I need to walk you through this whole script step by step. You should get the idea of it. What we will do together in this video is we will define a new workflow for one of my GitHub repositories where I'm storing an application template for a web server. So this is just a simple Nginx web server that I want to deploy on my Kubernetes demo cluster. This is the GitHub repository. You can see I've created 3 separate YAML files in here. There's one for my application deployment. This just runs a simple Nginx web server with a single replica somewhere on the cluster, and another one that will add a service object, and a third one that will add an ingress object. To deploy all of this on my Kubernetes cluster, I would now typically just clone this repository on my Mac and execute the kubectl command on all 3 files. And this is exactly what I'd like to automate in a GitHub action workflow. So whenever I make changes to these manifests and the code, the workflow should trigger a new kubectl apply command to make these changes happening on the cluster without having me to do it manually all the time. That's roughly the idea of it. I know it's just a very simple example, but that's how you can make your life a lot easier. And once you know how it works, you can translate this knowledge to automate any kind of task that you want. Okay, so one question you might now have is, where do these GitHub actions actually run? Because if you have a shell script or you want to execute any deployment commands like the kubectl command, you would typically need a computing instance with a specific environment to execute that code. And that is exactly basically what GitHub is doing in the background. So for any workflow that is triggered in GitHub Actions, GitHub will spawn a new process on one of their cloud machines that will execute a single job at a time, and these machines are called the GitHub Runners. GitHub provides these runners with different types of machines and operating systems installed with systems such as Ubuntu Linux, Microsoft Windows, and macOS. This is how you can get started pretty easily. You don't even need to set up a server for it or install anything. You just need a GitHub repository, and then you can start defining all your workflows in YAML files completely for free, and they will be executed on one of the GitHub's cloud runners. However, in a Homelab situation, we usually have our own protected network where we are hosting our own services, like I'm running my Kubernetes cluster with K3s locally, and if I'd now like to execute my workflows to apply any manifests on the local cluster, I would somehow need to allow access from outside to my infrastructure at home so that the GitHub runner in the cloud would be able to connect to it. Just to say, you could technically do it this way, but I actually don't like this idea, to be honest, because I prefer to run the actual commands and workflows inside my own controlled environment. And this can also be done pretty easily by just using the exact same software that GitHub is running on their cloud and just run it on one of my virtual Linux machines. I'm still using the GitHub platform to host my repositories and trigger the events, but the actual runner that will execute the job and the commands will run as a self-hosted instance in my controlled environment. GitHub allows you to set up these self-hosted runners also completely for free, and it's, in my opinion, a much better way to connect to any local environments, especially if you need to control access to internal resources. They are probably making it free because it's also saving GitHub some cloud resources because they don't need to compute the actual workloads, so it's a win-win situation for GitHub and for you as well. By the way, if you're having trouble following this tutorial because you're not running a Kubernetes cluster in your Homelab yet, or you're not sure about how to set up a virtual Linux machine to install the GitHub Runner, then check out my YouTube channel. I'm always doing tutorials about Homelabs, and I also have a series about Kubernetes and running my own virtual Ubuntu machines on Proxmox. I'll put you some of these interesting videos in the description of this video, so just check it out whenever you have questions. What you need to follow this project, in addition to a Kubernetes cluster, you also need a GitHub account, of course, but don't worry, as I said, it's completely free to get started, so you can just sign up on GitHub, create a new account, and just use GitHub Actions. And when you go into the settings menu, you can just go to Actions, Runners, and here you can create a new self-hosted runner that you can deploy into your own Homelab infrastructure. You can install it on any type of operating system like macOS, Linux, or Windows. I prefer using a virtual Linux server in my Homelab that I've created on Proxmox, but technically you can of course just use any other infrastructure you like. You can install it in a VM, you can install it on bare metal, or just run it in a Docker container. It's completely up to you. And I quickly want to show you how you can install the runner software on a Linux machine. It's actually pretty simple. You just need to follow these instructions here below. Create a new repository folder for the GitHub Runner and enter it. Download the latest runner package from the GitHub servers. Extract the archive. And then run the configuration script with the URL of your organization account on GitHub and your secret token. When you have configured the runner, you can simply start it with the run script, but if you'd like to make this a background task that is managed by systemd, you can also enable it as a service. This can be easily done by just executing the svc script with a installed parameter. Once you've started this service and it's active and running, you should see your self-hosted runner connected to the GitHub platform. You can see my self-hosted runner is now in the idle mode, so that means it's connected and awaits further instructions, so it's ready and waiting to execute our workflows. One thing that I should probably mention here is, depending on which types of workflows you'd like to execute on a runner, this might require specific applications or libraries to be present on that operating system. For example, when you're creating a workflow automation that includes command line tools such as Docker, kubectl, Ansible, or maybe Terraform, you would need to install these things on the runner system first. In our case, the workflow that I'm creating in this video here uses the kubectl command to deploy the web server onto the Kubernetes cluster. And what the runner does when the workflow is starting, it tries to spawn a new Docker container that has the kubectl tool built in and executes the actual commands inside this small container. When the workflow is completed, it removes the container again, so it's just a temporary container to be able to run the kubectl command. That means you don't need to install the kubectl command itself on the runner's VM, but you need to install the Docker engine and CLI so that the runner can use these tools to create the container. And the user account where the runner service is started with also needs the permissions to access the Docker CLI. Basically, you can simply install the Docker engine on Ubuntu via apt, add your current user to this Docker group, execute the new group command on your user account, and now we have everything ready. Okay, great. So now that we have installed the whole environment, and yeah, I'm sorry, I know this video requires a bunch of different things to be set up and installed, yeah. We have set up a GitHub account with an organization, we have configured the runner, installed the right tools on it. Now we can finally start creating our project. And what I'd like to do with you is, I've already cloned this repository here that I've shown you before on my Mac. Let's open it in VS Code. Now to create our GitHub Actions workflow, we first need to create a new dot folder called GitHub. So this is where you usually store all configuration files relevant for GitHub. And in here, we need to create a new folder that is called workflows. This is where we just need to put our workflows in. It needs to follow a specific format to be recognized by the GitHub Actions platform that usually is a YAML file. I'll just give it the name Kubernetes deploy.yaml. And in this file, we will first need to give it a name. I will just give it the same name as the file name. And now we need to define on which type of events this workflow is triggered. Remember, we can trigger it based on all sorts of events happening in this Git repository. In the official documentation, you can look up what are the possible types of events. Mostly, you would use something like a pull request or a push. A push, for instance, is always triggered if you change code inside a GitHub repository and upload it. So that's exactly what we want. And you can also specify to which branches this would apply. So if you have a large repository with different branches like main, staging, development, and so on, this will be very useful to you. I usually tend to keep it just simple. And for this repository, we only have the default branch, which is called main. So only a push to the main branch will execute this specific workflow now. Okay, great. So now we can define the different jobs in here. I will start with only one job that should execute a couple of different steps and commands. I'll call it deploy. And here we need to define on which runner this job will be executed. Note that you can define different jobs in this workflow to be executed on different runners because we of course want to use our self-hosted runner that we have installed. I will just use it here by adding self-hosted. And now we can start telling the runner what it actually should do when the job is executed. Let's start with a very simple step called the checkout code. This will basically just clone the repository into the runner's temporary container file system so that all the other steps we will define later all have access to the code from our repo. And we actually could just run it and already test it, even though this would not really do anything. But I'd like to do a quick test now. So let's just see what happens when we push this code to GitHub. So let's add the workflow file to a new commit, name it something like initial testing, and then let's push it. You can see what's actually happening when you open the repository on GitHub and then go to Actions. There you can see our workflow, which is now running. And if you click on it, you can see the actual job containing all the steps that we have defined. Currently, that's of course only the checkout command, but you can already see all the input and output of the console, everything that is happening inside the runner. So you always have full visibility of all the commands that are executed in GitHub Actions. It's pretty useful for troubleshooting and logging some of your automated actions. I will show you later why this is important. As you can see, our runner has executed our checked out code command, and if we go back, Everything was completed now and the workflow has ended successfully. This is basically how you can get started with GitHub Actions. I would strongly recommend start playing around with it and test it in a repository like this. Maybe execute a few hello world commands to just see how it works. But let's now do something actually useful with this. As I said, in this project, I want to deploy these free manifests here on my Kubernetes demo cluster. So we need to add more steps to this job in our workflow that will execute the kubectl apply command on all of these files, just like you would do it manually in a terminal on your PC. Now, typically you can do this in GitHub Actions pretty easily. You can just define regular shell commands in a workflow that your runner would then execute. This would absolutely be a way to do it. However, there is a much easier method to do this for kubectl and Kubernetes in particular, because in GitHub Actions you cannot just run simple shell commands on your runner. You can also utilize predefined environments for GitHub Actions that already come with various tools installed, such as kubectl, or maybe you want to do something else with Ansible or Terraform. There are so many of these environments around that were created for these specific tasks, and you can even create custom environments for GitHub Actions. You can find them on github.com/marketplace and search for something specific in here. Make sure you will select the type actions first, otherwise you would also see the GitHub apps in the search results. And then you can start browsing here to find something useful. Just a side note, as you can see, this is mostly driven by the community or the developers of the specific tools. So always take a look at who has created this environment and if that's really what you'd like to use. For example, GitHub maintains a repository called Actions Hub. So this provides GitHub Actions environments for Docker, kubectl, and a few other ones. And especially the kubectl environment contains some useful additions to handle authentication properly. So that's why I'm using it in this tutorial here. Because one thing is pretty clever here. When we want to authenticate to my Kubernetes demo cluster, we would of course need to provide credentials to the self-hosted runner. Otherwise it has no permissions to execute the kubectl apply command on my cluster. And you can define those types of secrets in the GitHub repository and use them in all of your projects. This is a very secure way to store sensitive credentials that the runners need. To do that, we just need to go into the repository settings. And in here, there is a menu called Secrets and Variables. Go to Actions, and here let's just add a new secret that I call kubeconfig. And this is where you can put your kubeconfig file in that you use to connect to the Kubernetes cluster. Note, you can't just copy this file and place it in here. Unfortunately, you first need to convert it to base64. So I'm simply just using this quick command in my terminal. This will take the output of my entire kubeconfig file from my Mac. That includes all the credentials and the IP address and settings to connect to the right Kubernetes cluster and pipe it to the base64 encoder. Then I can copy the entire output and just paste it into the secrets variable in the GitHub repository. Now that we have done this, we can just use this environment variable stored in our repository in our workflow right before the checkout command is happening. So this environment variable will be globally accessible on all the jobs inside this workflow. And now we can finally start adding our kubectl commands to deploy our manifest files. I will just create 3 different steps here for each of these files using the environment from the Actions Hub and the tool kubectl. The first one will just run the kubectl apply command at the deployment file. This will just run and deploy the application. The next command will apply the service object. And the last one, the ingress object. That should be all that we need. So now that we have everything ready, let's commit these changes to the GitHub repository. And then we just need to push it again. Let's go into the GitHub Actions to see if the runner has executed all of these commands as expected. There you can see our job is currently running, so let's have a look inside what's happening. But as you can see, the initial deployment workflow just exited with an error. If we take a closer look at what's happening here inside the job that was executed, and the step that was failing, you can see this is one of the things that I also wanted to show you because I'm running the Kubernetes tool Datree on my cluster, which I've mentioned in the beginning of this video. And this tool prevents GitHub Actions to deploy anything on the cluster that violates its policy. Just a few words more to Datree. This is an amazing tool to secure Kubernetes and prevent misconfigurations. When we'll take a closer look at the activity log in Datree, you can see why it failed the policy check on cluster demo 1, and that's because the container image that I'm using in my deployment manifest doesn't have a pinned tagged version. So I'm not allowed to use the latest tag in the container images, and that totally makes sense, because when you're using the latest tag on your automation scripts, you never know which version it will deploy. And it could actually have some breaking changes in your versions that are not compatible with your configuration, so it totally makes sense to avoid using the latest tag in your deployments and only do updates to newer versions manually. I've, by the way, recently made a more detailed video about Datree and how to use it to protect all your Kubernetes clusters with policy checks. Datree gives you the opportunity to use their entire feature set on one of their Kubernetes clusters completely for free. So that's really amazing. If you want to learn more about it, I'll link you my first tutorial video in the description down below. So check it out and just test it in your Homelab. Okay, so like I said, the policy tells us to change the latest tag on the deployment container image to something more specific. So let's just check what is the latest version of the Nginx web server on the Docker Hub. Put this version tag into the container image, and now our GitHub action should run correctly. We just need to commit this new change to the repository again. And if we now go to this job, you can see all the steps were executed correctly. That is a good sign. If we execute the kubectl command to get our deployments and resources in the Nginx demo 2 namespace, that's what GitHub Actions should have deployed. You can see there is our new deployment that was created by the GitHub Runner. And here is our web server. Isn't that cool? I haven't done anything manually. I mean, except all the configuration for the GitHub Runner and set up the workflow. If you're now saying, well, that's a lot of work, I would have done that much faster by just executing these 3 simple commands on my Mac. Yes, you're right, but automating your projects is always a lot more work upfront. Don't be worried, you'll get the payoff later in the process, because if we now need to make any changes to this application, for example, let's try to change the domain in the ingress object to maybe second Nginx kube demo 1, yeah, just for testing it. I now can just commit this new change to GitHub, push it, and after a few seconds, this change was automatically applied by the GitHub Runner without having me to authenticate to the cluster and execute any command. And just like this, you can automate a lot more stuff. Also, you can fully utilize all the tools from GitHub, like roll back any changes when something doesn't work. It takes some time to get into all of this, I agree, but for managing larger projects, I think this is such a useful tool. To be honest, I'm pretty excited about this because I can use it in so many different ways in my Homelab. I could combine this with Terraform to deploy all my infrastructure, or I could automate the deployment of all of my Homelab applications and servers, or run regular security checks on them. I will need some time to figure out how exactly I'm going to use it in my Homelab. These are just some ideas that came up in my mind. If you have any other ideas, just put it in the comments below. And if you're interested, I'll show you a couple of projects I'm doing with it in a few months. Anyway, I think that's enough for today. I'm sure you now want to try it out yourself. Please let me know if you have any trouble or questions. And as always, thanks everybody for watching. I will catch you in the next video. Take care. Bye bye.